The Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the occurrence of elements. This is our second lesson on this topic. In our last lesson, we learned that a mineral is a solid substance that occurs naturally in the Earth's crust. We learned that ores are minerals from which elements can be extracted both easily and economically. We also learned that while ores are always minerals, minerals are not always ores. This is because there is not always enough pure element within minerals to make extraction financially viable. We discussed elements that are found in a free or native state, such as gold and silver. These are less reactive metals. We also learned about elements that are only found in compound state, such as potassium and sodium. These are extremely reactive metals. Students, here is an interesting list for you to remember. These are the 12 most abundant elements in decreasing order of abundance in the Earth's crust. Oxygen, silicon, aluminium, iron, calcium, magnesium, sodium, potassium, titanium, hydrogen, phosphorus, and manganese. These elements make up 99.7% of the Earth's crust. That is amazing. Let us look at the top 6 elements in more detail. As you saw on the pie chart, oxygen is the most abundant element on Earth. It constitutes about 45.5% of the Earth's crust by weight. It is found in the form of compounds such as oxides, silicates, carbonates, and phosphates. It also keeps us alive. Silicon, although very common, rarely occurs as a pure, free element in nature. It is most often found in dusts and sands as various forms of silicon dioxide or silicates. Silicon makes up about 27.2% of the Earth's crust. Aluminium is mostly found in bauxite ore. It is the most abundant metal in the Earth's crust at about 8.3%, and it is the second most important metal in terms of global consumption. Iron is the most highly consumed metal, although it is the second most abundant metal in the Earth's crust. It occurs in compounds, namely oxides, carbonates, and sulfides, and it comprises over 6% of the Earth's crust. Calcium is the fifth most abundant element in the Earth's crust, constituting about 4.7% of the Earth's crust. It is essential for living organisms, and it is a major constituent of bones and shells. The element magnesium is also essential to all living organisms. It makes up just over 2% of the Earth's crust by weight. Magnesium compounds are typically white crystals. This metal is often used in alloys for its low mass and high strength. The Earth's atmosphere, in case you were wondering, mainly contains nitrogen, oxygen, argon, carbon dioxide, and other trace gases. Students, in our last lesson, we discussed the three categories that elements of the periodic table fall into. Can you remember what they are? Try to write them down now and define each.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. If you said that elements are classified as metals, nonmetals, or metalloids, you are correct. But how do we define these categories? Let us go over these definitions together. Metals are elements that are characterized by good electrical and thermal conductivity. They also have luster, high density, and the ability to be deformed under stress without cleaving. Metals form cations or positive ions and ionic bonds with non-metals. While there is no specific definition for non-metal, as this term covers a wide variety of elements, there are several common properties that are considered to be characteristic of non-metals. Non-metals are poor electrical and thermal conductors. They often have low densities and are dull and brittle when they are in a solid form. Non-metals have high electronegativity. This means they have the tendency to attract electrons and thus form negative ions. While the majority of elements on the periodic table can be classified as either metals or non-metals, there are a few with intermediate properties. We refer to these as metalloids. The line that separates metalloids from non-metals on the periodic table is called the amphoteric line. You can remember this because metalloids often form amphoteric oxides. They also often behave as semiconductors. We just went over some long definitions for the classification of elements. If you answered some or all of that correctly, great job. Students, let us do another activity. Please list the 6 most abundant elements in the Earth's crust and then classify them as metals, nonmetals, or metalloids.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Were you able to remember which elements are the most abundant in the Earth's crust? If you said oxygen, silicon, aluminium, iron, calcium, and sodium, great job. Those are correct. Oxygen is a non-metal. Silicon is a metalloid, and the others are metals. In today's lesson, we learned about the distribution and relative amount of elements in the Earth's crust. We discussed these elements, including oxygen, silicon, aluminium, iron, calcium, sodium, and several others, and classified them as being metals, nonmetals, or metalloids. In our next lesson, we will discuss the carbon cycle. This is all the time we have for our lesson today. Until next time, thank you, teacher. Thank you, students.